Alrighty, course report. This is page 7 in your course report binder. Sorry, it's a video. Whoa there. Sorry, something popped up on my computer. So we are going to work through this. Let me get something real quick. So you will have this too. It's patty paper. It's like tracing paper. It's wax paper. It's kind of see-through, so you can use it on different things. So a rotation is turning a figure around a fixed point called the center of rotation. For example, the center of rotation will be for us, it's almost always going to be the origin. And I say almost always because sometimes there won't be a grid drawn for you. This one has no grid. That's just showing the rotation, actually. So there won't be a grid to show what the origin is. So sometimes there isn't one, but we always try and make it around the origin. And we will rotate in increments of 90s. So we have 90, 180, 270. You could do 360, but really that's putting it back where it was. Figures can be rotated clockwise. Whoops. That's not an I, that's a W. Or counterclockwise. So clockwise is the way the clock moves. So if this is 12, we have 1, 2, 3, and see how it's moving in the same direction the clock does? Or counterclockwise moves in the opposite way. So clockwise is kind of like turning to the right, counterclockwise turning to the left. So if I'm here, I'm going this way. Start here, I'm going to go this way. That's right. Start here, counterclockwise, backwards, left. In problems 1 through 3, use the number of quadrants the figure was rotated to describe the degrees of the rotation. Remember, going from here, from one to the next quadrant is one turn, so that means it's 90 degrees. So if you go 2, 90 plus 90 is 180, plus 90 is 270, plus 90 is 360. So if we are going clockwise, we went one quadrant. That's a 90-degree turn. If we went counterclockwise, we went 1, 2, 3. Well, each one of those is 90, so we have 270. B, going clockwise, we go 1, 2, 3, so that's 270. Going counterclockwise, 1, so we got 90. From C to C, clockwise, we went 2, 1, 2, so we have 180. Going counterclockwise, we have 1, 2, which is also 180. When you have a rotation of 180 degrees, it doesn't matter if it's clockwise or counterclockwise because they're in the same spot. Number 4, use the rotation of triangle ABC, so this one because it doesn't have our little prime notation on it, to answer the questions below. ABC was rotated blank degrees clockwise, so from here to here. It is one quadrant, it is 90 degrees. And counterclockwise, going backwards, we went 1 quadrant, 2 quadrant, 3 quadrants. So 270 degrees. Complete the table. So your pre-image, all your points. We have A, B, and C. So A is 2, 3. B is 5, 8. And C is 6, 1. Remember, all your order pairs are always X, comma, Y. Your prime, your image point. So we have A prime, B prime, C prime. A prime is 3, 2. Oh, and this is negative 2 because we're below. Negative 2. B is 8, negative 5. And C is 1, negative 6. C. Describe how the rotation affected the values in the ordered pair. So we went from 2, 3 to 3, 2. 5, 8 to 8, 5. 6, 1 to 1, 6. So our X and our Y's flipped, and our Y values became negative. Okay. X and Y values switched. And Y value. This is the new Y value. Became negative. Write an algebraic rule for rotation. So our rule, because our X and our Y values switched and the Y became negative, we would have X, comma, Y is now our Y value, comma, negative X value. Next page. So ABC was rotated 1 turn, 2 turn, so 180 degrees clockwise, or 1 turn, 2 turn, 180 degrees counterclockwise. So our points were 2, 3, 5, 8, and 6, 1. Our new points are negative 2, negative 3, negative 5, negative 8, and negative 6, negative 1. So our rule is we went from X, comma, Y to negative X, comma, negative Y. Six. Clockwise, 1 turn, 2 turn, 3 turn, 207 degrees, or 1 turn, 90 degrees. You come up with your image and your pre-image and your post-image, and the rule would be X, comma, Y, and then what happens to my X and my Y's. 7. Describe what would happen if a figure rotated 360 degrees. How would you represent the rotation of a 360 degree algebraically? So if we are here, and my image moved 360 degrees, 1 turn, 2 turn, 3 turn, 4 turn. There's 360 degrees. Where is my image? Well, it's in the same spot. So algebraically, my X and my Y remain my X and my Y. Using what we know about rotations, we need to figure out how many degrees was our image rotated. So this gives me an x and a y and the new xy, xy, new xy, based on the rules we wrote down. So we have this one written down. This one we don't. So I will give it to you. Our y, our x was 2 and it became 3. So our x becomes our y value but negative, and our y became our x value. So now you know those. So you can look back and you can look at these and decide what happened from your x and your y to your new x and your y. 10. A triangle ABC has the coordinates shown below. Jamie will rotate the triangle using the rule xy is now y negative x. Describe the possible degrees and directions of the rotation. List the coordinates of A prime. Possible degrees and rotation. Well, if this is our rule, that one was this one. XY became y negative x, and it was 90 degrees clockwise. So 90 degrees clockwise, or the opposite of that would be 270 degrees counterclockwise. A prime would then become our y value, so negative 1, and a negative x. Well, we would have negative 5, which becomes a positive 5. Number 11, try it on your own. And then check back in Google Classroom and see what your next assignment might be.